2011 question 9. That's 2011 question 9. In a photoelectric setup, three metals M1, M2, M3 with work functions phi1, phi2 and phi3 respectively with 0 less than phi1 less than phi2 less than phi3, basically saying that phi3 has the largest work function and they are considering the values in magnitude. So that's 0 is there, less than 5. Okay. Are illuminated with light of frequency nu and wavelength lambda. The currents I and voltages V are registered. The stopping potential and the cutoff wavelength are denoted by V naught and lambda naught respectively. Which plot below could be a possible outcome of the experiment? In A we have got current against stopping potential. In B we have got stopping potential against frequency. In C we have got stopping wavelength or cutoff wavelength with work function. And in option D we have got stopping potential V naught with wavelength. Okay, now let us start with option B because it deals with straight lines. Okay, Kmax is equal to h nu minus phi naught, but that Kmax is given by EV naught, where V naught is the stopping potential. Okay, now look, why should we reject B? Because no matter what the phi naught is, work function, the plot of V naught versus nu is going to be a line with constant slope. Okay, I should say a line with the same slope. Okay, that slope is going to be h upon e. Now because the lines in option B have different slopes, right? Lines in option B have different slopes. Can that be true? No. Because lines have different slopes, can B be right? No, B cannot be right. Raise your hands if you have understood why B is not right. Okay, great. Now let us come to D, because D happens to be related to B. Only thing that has changed is the variable on the x-axis. Okay, the variable on the x-axis. So let us continue with the EV naught is equal to h2 minus phi naught, and I can write EV naught is equal to hc by lambda minus phi naught. Okay, EV naught is equal to hc by lambda minus phi naught. Got it? Now let us consider some wavelength. Okay, let lambda be equal to, let us say, lambda prime. Okay, and let that lambda prime be somewhere here. Okay, let that lambda prime be somewhere here. Let me zoom in a bit. Okay, yeah, let's take a bit leftwards. Okay, let's take it here somewhere. Lambda dash. Okay. And now what we are going to find is, we will be finding the values of V naught with the values of stopping potential for this particular wavelength. Okay, this particular wavelength. Now look, the third curve, okay, or the one that is this one, that is going to give me V1, right? That's going to give me the stopping potential for 1. Then this is going to give me the stopping potential for 2, and the bottom one is going to give me the stopping potential for the third one. Okay, and you clearly see that V1 is greater than V2 is greater than V3 as far as the graph is concerned. Okay, as far as the graph is concerned. But does it meet the requirements that the problem poses? Let's see. Okay, so basically we are considering the same wavelength. Okay, now look, from graph, right, from the graph for given lambda prime, v1 is greater than v2 is greater than v3. But what data we get from the problem? From problem statement. From problem statement, they are saying phi 1 is the least, phi 3 is the greatest. Okay, phi 1 is the least and phi 3 is the greatest. Now we just need to confirm whether the given things agree with what they say. Okay, look, if phi 1 is the smallest, okay, look, if phi 1 is the smallest, then hc by lambda dash or hc by lambda prime, hc by lambda prime minus phi 1 should be greatest or largest. Is it true? Is V1 greater than other two? Yes, right? Raise your hands if you get my argument. I am saying if phi 1 is the least, okay, that means you are subtracting as small a number as possible from the given set of numbers phi 1, phi 2, phi 3. Okay, hc by lambda is constant because we have fixed lambda prime. Okay, we have fixed lambda as lambda prime. So for a given wavelength, hc by lambda is a fixed value. Now, to get the largest value on the left side, that of V naught, we need to subtract the least one, that we need to subtract phi naught. Okay, we need to subtract phi naught. Now, does that make sense? If phi naught is the least, then V naught must be the largest. Okay, so for V1 should be largest, and it is from D. So shall we go with D? Yes, we have to go with D. Okay, we have to go with D. But let's also argue why A and C are not right. Why A and C are not right? Let's see. Why A and C are not right. Okay, why A and C are not right. Now look. In C we have got cutoff wavelength lambda naught with stopping potential phi. Now what is stopping potential? Oh sorry, not stopping potential, not stopping potential, work function. Okay, work function is h nu naught. Right, work function is h nu naught, which is hc by lambda naught, which means phi shares an inverse relationship with lambda naught and not phi proportional to lambda naught. So because it is not a linear relationship, it's a hyperbolic relationship, so C is not right. Okay, C is not right. Now why can A be not right? Well, the reason is because D is right, but let's argue about A. In A, we have got the current, photocurrent versus potential, collector plate potential V, and on what you see in the first quadrant, is our saturation current. Okay, and what you see here as the intersections with the V axis, they are the stopping potentials. Okay, now look, let us again write down this expression. EV naught is equal to h nu minus 1. Okay, h nu minus 1. Now look, if, okay, for given photon, h nu is fixed. Right, what does it mean? It means if phi naught is smaller, okay, if phi naught is smaller, then V naught must be larger. Raise your hands if I understood this point. If phi naught is smaller, then V naught must be larger, because the incident energy is h nu. A smaller portion of that is being utilized to overcome the Coulomb repulsion imposed by the atoms or the ions of the metals. Which means if a smaller fraction of the incident energy is utilized for that, a greater fraction will be available, and it will manifest itself in terms of the kinetic energy. That's EV naught. So greater the kinetic energy, greater the V naught. Okay, so what can we write? Okay, what can we write? Phi naught is smaller, then V naught must be larger. So which one has the largest value? So V naught 1 greater than V naught 2 greater than V naught 3, but this is in magnitude. This is in magnitude. Okay, so when it comes with the sign consideration, okay, what should be the graph when it comes with sign consideration? Let me draw it here now. Let me draw it here with sign consideration. Let me pick the same one. Let me pick the same option, but let me modify it now. Let me modify it. Okay, let me modify it. This should be M1. This should be M1. Okay, because that stopping potential V1 or V naught 1, that's greater in magnitude but negative in sign, and this should be 3 V naught. Hope you understood that, and therefore A is not right. Raise your hands if you understood that. Okay, therefore A is not right. So which option is correct? Which option is correct? D is correct, not C naught. Okay? Okay, fine. Well, you also can say that for A, at least with the right option that we have got here. Can you tell me on which metal is the beam of greater intensity incident? Or can we not conclude anything on that? I don't think we can conclude about the intensity, because this is not the same metal. These are different metals, right?